All right, so I'm going to read you the prompt, which is right below the jump start. It says, a couple years ago, Carlos and Clarita started earning money by taking care of pets while the pet owners are away. Due to their amazing mathematical analysis and their loving care of the cats and dogs that they take care in, Carlos and Clarita have made their business very successful. To keep the hungry dogs fed, they must regularly buy Brutus Bites, the favorite food of all the dogs. All right, then it goes on to say, Carlos and Clarita have been searching for a new dog food supplier and have identified two possibilities. The Canine Catering Company, located in their town, sells 7 pounds of food for $5. Customers buy the food in bulk so they can purchase any amount. The amount of food purchased often includes fractions of a pound, such as 2.6 pounds or 3.9 pounds. Okay? So here's our first question number 1 in your book. Carlos thought about how much they would pay for a given amount of food and drew this graph. So he drew a graph according to how much this company is selling the dog food for. Your job is to make a table based on this graph and then write an equation based on the graph or based on the table. Okay? Carlos graphs using D for dollars and P for pounds, so you can use those variables in your equation. So I'm going to give you guys 5 minutes, create a table according to the graph that you see, and write an equation. As soon as you're done doing both, talk to your neighbor, see if they got the same thing that you got. Okay, 5 minutes. And if you're stuck, if you're not sure how to do the table or how to write the equation, talk to the people in your group. So if you're not sure how to do it, ask your neighbor. They may know how to do it. Okay, if you haven't done so already, share what you have with your neighbor, and then we'll pick on someone to answer to see what they got for number one.
Basically, I just D times 1.4 equals
After F and T.
I completely forgot all that stuff, so I just decided just
Yeah, it's one question. And that's equals 1.4, so that's times it from pounds. 1 pound is 1.4, right?
1 pound is 1.4. Well, dollars. Whatever dollars. I kind of figured this one out because if you look right here, you multiply this by 2, you're gonna get 10, 14. And I just divided this by 10, this by 10. So you get 1 and 1. That's how I get it.
I guess that. Did y'all get an equation? Any of y'all got an equation?
Well, we're still going over it again, so did you get
Huh?
the equation?
We're on it. I mean, kind of.
Okay.
Alright, so, Jaden, right?
Yeah.
Do me a favor, pick a number 1 through 10.
9.
1, 2, 3, 4, 5, 6, 7, 8, 9. Tell me what you got for your table. So I'm gonna go ahead, first of all, let's talk about how you set your table up. What variables did you use for your input and output? Just, it's okay if you're wrong. Tell me what you got.
We have pounds as
Input?
the.
Okay, so pounds are the input. What's your, so then D for dollars for output? Okay, good. Now, what numbers do you have for your inputs? Just read me the numbers that are in your table.
1, 2, 3, 4, 5, 6, 7.
Perfect. 1, 2, 3, 4, 5, 6, 7. I would have done exactly the same thing. Now, what is the dollar amount you got for each one? So for this first one, what was your output?
0.75.
0.75? What was the next one?
150.
150? What was the next one?
225.
225? What was the next one?
3.
$3 even?
Yeah.
What else?
375.
375, okay.
450.
450,
And
525. Alright. So, before we move any further, in the prompt in the beginning, it told us how many pounds are sold for how many dollars. What did it tell us in the beginning? 7 pounds for $5, right? So there's some tweaking that we need to do to this table. I like this, I like the 1 through 7. This we're gonna need to fix. Did anyone else in your group get something different than this? You got something different? Alright, read to me what you had for the outputs.
Well, first I put $75.
Okay, good, so that's a good start. We know that for sure is correct.
And then I actually did increments of 2.5. I didn't do like 1, 2, 2.
Oh, okay, so talk to me about what your increments are.
So I had 2.5.
Okay,
Wait,
2.5.
no, 3.5, sorry.
Oh, okay, so you basically cut this in half.
Yeah.
So 3.5, okay.
And then I had a 10.5.
Oh, okay, so okay, I see what you did. Okay, that's clever. So then, if this is half, then this would also have to be,
2.5.
right, which is just half of $5. Okay, that's an interesting way to do it. And then from here to here, what would I do?
You would add 2.5 and
Very good. Which one will get me what?
7.5.
Okay, 7.5. Interesting. This is the first time I've seen someone do it this way. That is correct. Now remember, all of your tables are not going to look exactly the same. So someone may have something different. Okay? Do me a favor. I should have asked you your name. Your name is? Vanessa, because I got to start remembering your guys' name. Vanessa, do me a favor. Pick a number 1 through 10. 7. 1, 2, 3, 4, 5, 6, 7. All right. What did you get for your table?
I started at 7 pounds, $5.
7 pounds, $5, and then?
And then I just added 7 times so that I did 14 pounds is $10. 21 pounds is 15, and 20 is 20.
Okay, so you went in increments of 7. Okay. Do me a favor, pick a number 1 through 10.
4.
4. 1, 2, 3, 4. What did you do? Same as Malik. Pick a number 1 through 10. 8. 1, 2, 3, 4, 5, 6, 7, 8. Again, I gotta learn your guys' name. What's your name?
Joan.
Joan, that's right, Joan. Alright, Joan, did you do anything different than what we have already here on the whiteboard?
No, I haven't.
You didn't do anything different?
No, I didn't.
What did you do?
Oh, I did the same as Vanessa. I did the increments of 75.
Okay. Did anyone, just out of curiosity, did anyone do it like this? And none of this is wrong. Just to let you know, none of this is wrong. They started with 1, 2, 3, 4, 5. Maybe they worked their all the way down to 7. We know that this is $5. Did anyone try to fill in this part of the table here? And if so, what did you get? Okay, so what did you get?
For the first one, I put 1.4.
This is 1.4?
Yeah.
Okay, and then?
And 2.8.
2.8, okay.
And 4.2.
4.2,
And 5.6.
5.6,
And 7.
7,
And then 8.4.
8.4, and then?
9.8.
So for 7 pounds, you had $9.80.
Oh, no, I did the opposite. Like, I messed up.
You messed up? Okay. You're kind of on the right track. Anyone else do pounds 1 through 7 or 1 through 5? Go ahead.
For 1, I got 0.71.
Okay, so 71 cents, and then
And then 1.43.
$1.43,
And then $2.14.
$2.14.
$3.14, sorry.
That's okay.
No, wait, yeah, like for 3 pounds I got $2.14.
Okay, and then?
No, $2.14.
Oh, 2.14. Okay,
Yeah.
all right. And then?
And then for $4 I got $2.86.
Say that again. I'm sorry.
$2.86.
$2.86. Okay.
And then for for 5 pounds I got $3.57.
$3.57.
Yeah, and then for 6 pounds I got $4.29.
And then obviously for 7 pounds you got $5. Where did you get this number from?
From converting 5/7 into a decimal.
So you took 5/7, so I'm gonna, again, this isn't wrong, but I need some more space here. So you took 5/7 and you divided it, and when you divided it, you got, obviously you had there was probably more numbers that followed after, but you rounded. Where did 5/7 come from?
From the rise over one.
Okay, now you're mentioning rise over run. Where is 5, is 5 rising or running?
5 is the rise and then 7 is the run.
Okay. Now, since you have that, did you also write an equation? What was your equation?
For every dollar, well, every 5/7 pounds is equals dollars.
Okay, so for the dollar amount, right? For every 5 to 7 pounds, right? So if I have 1 pound, it's gonna cost me 5/7 of a dollar. 5/7 of a dollar is 71 cents. And then did you just basically start plugging in the numbers from here? And then, I'm sorry, your name is?
Alexa?
Alexa? So did anyone else does anyone else have the same equation as Alexa does? So I see some hands up here. Okay. All right. Now again, what I'm going to show you, again, here's what the textbook has. Your table may be different than the table that's up here. Like the table that you have is correct. There's nothing wrong with your table. We had another table, I forget whose table it was that I just erased. That table was also correct, okay? But this is a table that they provide here. Pounds 1 through 7, and then they broke it down here. You definitely should have this equation though. This equation is the equation that works, okay? Any questions on number 1?
Okay, so we were dealing with money, right? So we stopped after the 100 past the decimal. So if it was, let's say the third one was like a 5 or a 6, 7, would we round like that one up to a 2 or no?
You're talking about like if there was another number that came
Yeah.
after this? Yeah, in fact, all of these are rounded. These are all not perfect numbers. If you plug 2, so 2 times 5 is 10, 10 divided by 7, it doesn't come out as a clean 1.43. There's numbers that follow after it. So all of these have been rounded to 2 decimal places because we're dealing with currency. Good question. Any other questions with problem number 1? Okay, let's move on. So, problem number 2. It says, Clarita thought about how much food they could buy for a given amount of money and drew this graph. So now Clarita is thinking of the inverse of this relationship, right? If the inverse of the relationship is, now let's think about what Carlos did. Carlos did pounds as the input and dollars as the output. But now Clarita is thinking, well, what if I come to the store and I tell the store owner, hey, I only have $15. How much dog food can I buy for $15? Right? So now the dollars becomes the input because she's asking the store owner, hey, I only have $15. How much food can I buy? And then the owner would say, oh, you can buy X amount of pounds for that amount of food. Does that make sense? So she's basically taking the inverse of that equation that Carlos has, right? So if I'm taking the inverse of this, she's drawn the graph of that inverse. Your job for number 2 is to give me the table of that inverse relationship and the equation, basically the inverse equation of what Carlos did, because basically Clarita is doing the inverse function of what Carlos did. Does that make sense? Yes? Okay. So go ahead, take about 3 to 5 minutes, do the inverse of the, or basically take the graph, create a table, create an equation. Okay? Like I said, I'll give you about 3 to 5 minutes.
Yeah, this is where we messed up, we're doing this one instead. Yeah, it's rounded down, it's rounded down. Yeah, but this is basically it.
And if you haven't done so already, share with your neighbor what you have. See if you have the same thing your neighbor has.
My graph is very out of order.
I mean,
It's just 1.4.
yeah, one dog.
This inverse is a lot easier to do than the other one.
So I put $1 using multiple from.
Okay, so we left off with Alexa. Alexa, do me a favor, pick a number 1 through 10. 1, 2, 3, 4, 5, 6, 7. Oh, how did you get picked again? Okay, so what did you get for your table?
The input is the opposite, so D, and then E is the output.
Okay, so D is your input, P is the output, good. And then what did you put in here?
1, 2, 3, 4.
Okay, so you named, you went 1, 2, 3, 4, 5, 6, 7 again. Did you go up to 7 or just to 5?
No, just a 5.
Okay, that's fine, not a big deal. All right, and then what did you get for, the pounds?
1.4,
1.4,
and then 2.8,
2.8,
4.2,
4.2,
5.6,
5.6,
and 7.
and 7. Okay. So we know for sure, right, that 7 pounds buys us $5 of food, right? So we know that this is correct, right? And then, is it Vanessa? Okay, so did anyone else do it the way Vanessa did it? Okay, so I see a lot of hands. And then the table that Vanessa created, is that those same numbers? You have all the same numbers for those of you who did it Vanessa's way? Okay. All right, now there's different ways that you could have done it. Now your table does not have to match what Vanessa did. This is just one way to do it, okay? How many of you guys took this table and then just flipped it? Did anybody just do that? Did anybody say, okay, well, I'm just gonna take P and D and just flip it, and I'm just gonna take all these numbers and flip it? Anybody do it that way? No? Okay, that's also another possible way to do it. What other ways besides Vanessa's way, or taking this and flipping it, what other ways did we do? Did anyone do anything different? No? Yes, go ahead.
So what I did is for D.
Okay.
For D I put 5, 10, 15.
Okay, so you went in increments of 5, and then did you, I'm assuming 7, 14, okay, good. So again, you're just counting by 5s, but it's exactly the same thing, right? Okay. We'll go back to Vanessa. Now Vanessa, what is the equation that you came up with?
P equals 7 over 5,
Did everyone else get the same equation? Yeah? Okay, good. All right, so let me show you what the textbook has. Now, what the textbook, oops, wrong way. There we go. So, the textbook basically did it the same way that Vanessa did it, okay? Now again, if you did something a little bit different, but this equation works with the table that you created, it's perfectly fine. You don't have to erase it and change it, okay? As long as your table works with this particular equation, you'll be fine. Okay, any questions on number 2? We're good on 2? All right, let's move on to the next one. All right, number 3, it says write a question that would be most easily answered by Carlos's graph. Write a question that would be most easily answered by Clarita's graph. What is the difference between the two questions? Okay, so let's think about this for a minute. With Carlos's table, right, this was Carlos's table that we derived from the graph. What type of question could I ask given the table here and given the graph that we saw in problem number 1? Give me an example of what type of question I could ask based on that information. Go ahead.
How how many pounds can you get for $3.14?
How many pounds of dog food can I get with $3.14?
$2.14.
$2.14, I'd have to use the equation, but I could do it, right? So if I know the number of pounds, I can figure out the dollar amount. Would you agree? What about with Clarita? What type of question could I ask with the table and the graph from Clarita? Go ahead.
How many pounds of dog food can you get with $4?
Good. How many pounds of dog food can I buy for $4? Right? So, write a question for Carlos's graph, write a question for Carlita's graph, and then tell me what's the difference between the two questions. Take a couple minutes, write your own question down. Now remember, your question is gonna be different than the person next to you, so all of you guys should have probably a different question. But it's gonna work for Carlos's graph, and it's gonna work for Clarita's graph. And then tell me what the difference is between the two questions. I'll give you 3 minutes. After you've created your question, share your question with the people in your group, see if they got something similar. Of course, all of yours won't be the same.
How much money is needed to buy? How much money is needed to buy 1 pound of dog food? How much dog food could be bought with $1? Very simple.
I just put down how much the 7 pound dog food costs and how many dog food.
Yeah, I would, like for Carlos, I put how much does each pound cost? And for Claritos, I put how many pounds can I get for each dog?
Okay, so the answer that I have on the screen, it's a very generic answer because the textbook knows that all of you guys are gonna have different answers. So this very generic answer that they have for Carlos is this: how much would it cost, right? What is my dollar amount if you bought P pounds of dog food? So you could have wrote a question like, how much would it cost if I bought 3 pounds of dog food? Or if I bought 5 pounds of dog food? Or if I bought 1 pound of dog food, right? With Clarita's graph, again, here's this very generic question. All of yours are going to be different. How much food can I buy with X amount of dollars or D amount of dollars? So, how much dog food can I buy for $1? How much dog food could I buy for $3? How much dog food could I buy for $2, right? Any of those questions would match Clarita's graph and you could answer it, okay? They have approached the problem. Now remember at the end it said, what is the difference between the two questions? They've approached the problem by switching the dependent and independent variable. That's again another way of saying input and output, right? They've switched the input and output. Okay, any questions on 3? And again, all of your answers are going to be different. All right, let's move forward. What is the relationship between the two functions? What is the relationship they have? Starts with the letter I. They're inverses of each other. How do we know that? How do we know that they're inverses? They're the opposite. I see somebody poking. How do we know that? How do we know? She can open it. You can come in. How do we know that they're inverses of each other? Go ahead.
I'm trying to go for a wild guess and say that you can just input one and undo it by inputting the other.
Good. So one basically undoes the other one, right? So if I have inverses of each other, they're going to undo each other, right? Okay. So let me put on the screen what the textbook has. And again, your answer may be a little bit different. These two functions are inverses of each other. We know that part. The first part is they're inverses of each other. And just like Jaden was saying, we know that they're inverses because they undo each other. Now you could use some type of other type of terminology. I think you use the word opposite, right? That's basically the same thing. They give the same answer for a given number of pounds and dollars. Okay, so you don't have to copy this exactly. You can put this in your own words, but just basically capture the idea that they're inverses of each other and they undo each other, right? Or they're opposites of each other. So let me give you a minute, write that down, and we'll move on to question number 5. From last year, if you remember. Yeah, I do. Oh, okay. Do you have a prep period right now? Oh, okay. Let me write it down and I'll give it a second. Okay, any questions on number 4? All right, let's move on to question number 5. All right, so let me read you the prompt. So it says, looking online, Carlos found a company that will sell 8 pounds of Brutus bites for $6 plus a $5 shipping fee. So now we're dealing with a $5 shipping fee. The company advertises that they will sell any amount of food at the same price per pound. So the price doesn't fluctuate with the amount of food that's bought. Also, the shipping cost is the same. So they could order 1 pound, they could order 100 pounds. They're only going to charge $5 for shipping. So, problem number 5, we'll do problem number 5 first. Model the relationship between the price and the amount of food with a table, graph, and equation using Carlos's approach. So for number 5, draw a graph, make a table, and write an equation. I'm going to give you guys 5 minutes, and then we'll go over what you guys came up with.
This is terrible. The pricing. It's awful. It's way worse. Even without the flat $5 shipping, it's worse. ratio is worse. And it's a flat shipping cost. It's terrible.
I started doing that this year, and what I'm doing is not doing it, so that way if they use today's actually number, they can see it afterwards. So I'm trying it out, that's something that I'm trying to do. So we'll see how it comes out. Yeah, you just have to clear it with the school clerk, either with the school, maybe like the district office, I'm not sure how the process works anymore. But once you clear it with them, they'll send you an email and tell you that you're coming. You're welcome. So, Microsoft Teams is the application that they all use to access everything. So the laptop is connected to it. And so, just hit install and stop, and it just uploads it to Teams for that. So it's just a Microsoft Teams. There's a couple, it just depends on like what you're trying to do, whether it's like explaining certain stuff, or I use PowerPoint, there's also another app called Explain Everything. It's like a whiteboard app, I use that sometimes, it just depends on what you're trying to do. Like right now, it's just PowerPoint. Well, the content is very Microsoft Office heavy, so we're kind of forced to use Microsoft Office apps. So
It's still worse.
It's hard to do anything else unless it's like, it's a Windows app or Microsoft Office.
There's a question at the bottom.
Yeah, like the cell phone, it's just.
It's asking who should they buy from? They should buy from the other company. First one.
Like the laptop, like that's the schools, and so unfortunately, the office stuff. It's kind of amazing. Oh, if you, yeah, if you wanna, I have like 5 or 10 minutes I can spare after school if you want. Yeah. Yeah, anywhere there's an empty chair, you're more than welcome. Yeah, anywhere there's an empty chair. Yeah, go ahead.
Oh, so then, if this is basically $8 and so then £8. It's basically like the same thing like the last pizza, but instead it has a white insert, so it's always gonna start at 5. So it's basically 60 cents a year, and the rest is $5.
Terrible. Awful.
Okay, if you haven't done so already, share with your neighbor what you have.
Plus 5.
5 would be the minimum.
Five's in there.
Cause remember last, how you guys said like the rise over run gets you the equation? It'll basically get you the equation plus the shipping. So then you could just plug this in.
Okay, so for the sake of time, because we're getting close to the end of the period, I'm gonna put the answers up here on the screen. Now, as you're looking at this, did any of you guys get 6/8? Okay, is there a difference between 6/8 and 3/4?
No.
No, 3/4 is just a reduced version of 6/8. So if you have 6/8, it's fine. Okay, don't stress out that you don't have 3/4. Okay, 6/8 is the same as 3/4. Where did this +5 come from?
The initial shipping cost.
The initial shipping cost. So no matter how much dog food I purchase, I'm on the hook for at least $5 for that shipping cost. Whether it's 1 pound of food or 100 pounds, shipping is gonna cost me $5 on top of everything else.